Good morning, everyone. Thanks for attending my talk. My name is Abdelshiheed, and I'm about to start my last year as a PhD student at North Carolina State University. Today, I'll be talking about the power of nudging. We will be exploring three interventions to teach students metacognitive skills and whether these interventions will prepare students for future learning across intelligent tutoring systems. So let's get started. One fundamental goal of learning is being prepared for future learning. Preparation for future learning, or PFL, addresses the learner's capability to solve new problems in new environments and situations, and the ability of such learners to continuously learn. Substantial research has shown that despite the importance of PFL, it's actually hard to achieve. However, prior work has also shown that PFL can be facilitated by many factors, including metacognitive skills. For instance, such metacognitive skills included teaching, planning, monitoring, and evaluation skills, as in the beta and L, or observing awareness about different problem-solving strategies, as in our prior work. More specifically, in our prior work and in this current work as well, we focus on two metacognitive skills related to problem-solving strategies. Strategy awareness, which is knowing how to use each problem-solving strategy, and time awareness, which is knowing when to use each problem-solving strategy. To evaluate PFL, students are trained on two intelligent tutoring systems. First, on a logic tutor that supports two strategies. We're going to call them strategy 1 and strategy 2 in this presentation, with strategy 1 being the default strategy and strategy 2 being the alternative strategy. And then 6 weeks later, students are trained on a probability tutor that supports only strategy 2. In our prior work, based on the strategy used on the logic tutor, students were categorized into two categories. First, those who are both strategy and time aware, and that they know how and when to use each of the two strategies on the logic tutor. We refer to them as strategy and time. And their peers who simply followed and stick to the default strategy on the logic tutor, which is strategy 1, and we're going to refer to them as default students. We found that strategy and time students outperformed their default peers, not only on the logic tutor, but also more importantly on the probability tutor, where strategy and time awareness is not even an issue because there is only one strategy on the probability tutor. Therefore, it seemed that strategy and time students were prepared for future learning while their default peers were not. So what we do in this work is, in the current work, to make default students catch up with their strategy and time peers, we explore three interventions on the logic tutor for supporting the default students. In the first intervention, known as example, the assumption is simply that the key difference between strategy and time students and default students is strategy awareness, or in other words, that default students simply don't know how to use a strategy 2. And once we teach them the how part, they will spontaneously and naturally know the when part. So we just need to teach them the how part, and we do so by providing work examples on strategy 2. The other two interventions, the second and the third one, have a different assumption, is that the how and the when are two separate metacognitive skills, and you need to teach them separately. So we still teach the how part using the same work examples for strategy 2, but the difference is the approach of teaching the when part. For the nudge, the system reminds students about another strategy, like, hey, there's another alternative strategy, why not try to use it? But in the presented intervention, the system presents some problems by default in the alternative strategy and requires students to use that strategy. So let's start by the related work. Substantial research has explored the importance and the effectiveness of metacognitive skill instruction, or regulating strategy use, and allowing learners to compare different problem-solving strategies according to their feasibility and familiarity from the learner's perspective. More closely related to our work, a lot of prior work has shown the importance of strategy awareness on promoting invention skills and allowing learners to be aware of the limitation of each strategy, and also have shown the importance of time awareness on yielding high planning skills and long-term mastery of problem-solving skills that eventually leads to high academic performance. As far as we know, no prior work addressed both strategy and time awareness in an experimental study. So substantial research has explored teaching strategies by example, by nudging, or by directly presenting the strategy, and the results were mixed. Some studies found significant difference, while others did not. However, as far as we know, no study conducted a comprehensive comparison between the three types in a single study, and that's what we do here. Each study of those is described in details in the paper. So we start by the methods. Our participants, we had 230 computer science undergraduate students taking the discrete mathematics course at North Carolina State University. We needed to early predict the metacognitive label. So we previously trained a random forest classifier that turns out to be 97% accurate for this task. And we have two labels, default or strategy in time. We had 88 default students and 49 strategy in time. The point I want to make here is that strategy in time represents a small percentage of the overall population, only 21%. But the final numbers is the students who finished both tutors. So we had 111 students who finished both tutors, 71 default students, and we split them later into conditions. I'm going to come to that later in a minute, and 40 strategy and time students. So just to show you the two tutors and their different interfaces, so they are not identical at all. I start by the logic tutor. We have two strategies, the default strategy on the left. You start by givens at the top, and you keep progressing till you reach a conclusion at the bottom. The strategy 2 on the right, you start by the same givens and the negation of the conclusion, and you try to drive a contradiction. So strategy 2, you manipulate your original goal. Sorry. For the probability tutor, that's the interface. You have a target variable, which is your goal, and you also keep manipulating it till you eventually, in this case, reach the givens, the original givens. We have two windows for variables and equation on the left, and two windows for the right, on the right for the communication back and forth between the student and the tutor. So the procedure, at the beginning, students are assigned to the logic tutor, and then 6 weeks later, the probability tutor. So they start in the logic tutor by going over 2 pre-test problems, and then the logic training, which is 20 problems. And that's where the prediction happens. You need to predict their metacognitive label. And based on that, if it's strategy and time, we treat them as a golden standard, no intervention. If it's default, we randomly assign them into 4 groups, a control group that receive no intervention, and 3 groups that receive an intervention. And I'm going to explain what is the intervention in a second. But that's the only part that's different between the groups. Everything else is identical. So all students go over the same logic post-test and the same probability tutor, which is the standard sequence of textbook, pre-test, training, and post-test. So the original logic tutor, 20 problems divided evenly in 5 levels. So 4 problems at each level. Control and strategy in time, no intervention. All problems are presented by default in strategy 1. For example, for the example intervention, we provide 2 work examples on strategy 2. And then for the nudge intervention, we further add 6 more problems in which the system reminds people like, hey, why not switch to the other strategy? And this is an example of a nudge. Literally below the conclusion, we just tell them, for instance, it will save you time if you change to the other strategy. And then for the final intervention that presented those 6 problems in red, this time we presented in strategy 2 by default, literally, and we ask students to solve using that strategy. So our results, let's start by the logic tutor. We have 1 column per group, and we have 6 measures, 6 rows, each one for a measure. We start by the pre-test, 2 isomorphic scores, isomorphic post-test and isomorphic NLG, and then the overall post-test and the overall NLG. NLG is just a measure of improvement from the pre-test to the post-test. And finally, we have the training time in hours. So we started by comparing the pre-test and the training time across all groups. We performed a one-way ANOVA using the groups as a factor, and we find no significant difference in the pre-test or the training time between all groups. And then we wanted to compare the improvement on the isomorphic problems. So we performed several repeated measures ANOVA using pre-test and isomorphic post-test as a factor. We performed 1 repeated measure ANOVA per group. So we did like 5 repeated measures ANOVA here. And we found that only nudge, presented, and strategy and time groups learned significantly better on their isomorphic post-test compared to their pre-test. However, the control and example conditions did not learn significantly better on their isomorphic post-test. And then for the post-test, the overall post-test, we performed a one-way ANCOVA on the logic post-test using the logic pretest as a covariate. And using the group as a factor, we found a significant effect. Subsequent pairwise contrast analysis using Bomfroni correction found that each of nudge, presented, strategy, and time significantly outperformed each of example and control, and there was no significant difference observed between any of nudge, presented, and strategy and time. The same results were found on the NLG. I'm just presenting the post-test here. For the probability tutor, same thing. We started by comparing the pretest and time. A one-way ANOVA using the group as a factor found no significant difference on the training time or the pretest. And then we did again several repeated measures ANOVA using pretest and isomorphic post-test as two factors, and we found that nudge, presented, and strategy time also learned significantly better on their isomorphic post-test, while this did not happen in the control and example conditions. And finally, for the post-test, again, we performed a one-way ANCOVA on the probability post-test using the probability pretest as a covariate, and we found a significant effect. Subsequent pairwise contrast analysis with Bomfroni correction this time found that only nudge caught up with strategy and time, and they both significantly outperformed the remaining three groups. And that's the interesting part here, that we did not provide any intervention in the probability tutor. However, we had a group that catch up with a golden standard, which is strategy and time. That group was the nudge, and it happened in the probability tutor. The same results were observed on the NLG. Final result, we wanted to compare their logic behavior. So not only the logic performance, we wanted to compare the logic, their behavior on the logic tutor. So in our prior work, we found that the distinctive property of a strategy and time students is that they switch early from the default strategy to the alternative strategy. In this work, we found that the nudge group caught up with strategy and time in that behavior, and this was confirmed by a one-way ANOVA on the early switches. We found a significant effect, and subsequent chi-square test with the Bomfroni correction found that nudge indeed caught up with the strategy and time and switched early, significantly more than the other groups. Finally, the conclusion. The impact of our intervention on different conditions on the logic tutor, each of presented and strategy and nudge caught up with strategy and time, and they outperformed the remaining two groups. However, on the probability tutor, where there was no intervention, nudge caught up with strategy and time, but not presented like presented. They actually outperformed the presented group. So the takeaway from this paper and the presentation, that when we try to only teach the how part, like what we did in the example intervention, it was not enough. Example did not outperform control at all. There will actually no significant difference between example and control. However, when we added the time awareness factor, like teaching when to use each strategy, the significant difference was observed, for instance, in the nudge condition across two tutors. That's the main takeaway that I want to reach from my presentation, is that when you know when to use each strategy is a separate metacognitive skill and should be considered in a lot of future research. So limitations, that's my final slide. The conditions ended up with relatively small sample sizes because we had to split the students across the default students. And also, it would be ideal if the two tutors can support the two strategies without any default strategy, so that we can judge all students, whether all students can choose the appropriate strategy for each problem. I wish I can do that in the future work. So like implementing the other strategy on probability tutor also. I want to thank my advisor and all of my co-authors. And if you want to follow up with questions, feel free to reach out or email me. Thank you.